Hi guys, I'm again back with quantitative aptitude classes. So this quantitative aptitude is useful for bank POs and getting through the MNC exams, and this have much more importance in many fields. So let us learn the basics of quantitative aptitude. Let us start. So let us discuss the topic called numbers and quantitative aptitude, which plays important role. So what are the types of numbers? Types of numbers are natural numbers which starts counting from 1, 2, 3, so on up to infinity. Whole numbers which include 0, and every natural number is a whole number. Integers which starts from minus infinity to 0 and 0 to infinity. Positive integers are 1, 2, 3 to infinity. Negative numbers are minus 1, 2, 3 up to minus infinity. And others are even numbers, odd numbers. Even numbers are nothing but 2, 4, 6, 8, 10, etc. The numbers which are divisible by 2. Odd numbers are not divisible by 2. Prime numbers are the number greater than 1 is called a prime number if it has exactly two factors, namely 1 and the other itself. Then comes to composite numbers. Numbers greater than 1 which are not primes are called composite numbers. 1 is neither prime nor composite. 2 is only even number which is prime. There are 25 numbers between 1 and 100. This is very important thing. Note it down. The two numbers A and B are said to be co-primes if their HCF is 1. Now test for divisibility. First, how is the number divisible by 2? Sorry. If we can see many numbers like 2, 3, 5, 8, 9, 2. So these numbers can be anything, but we'll consider the units place. Units place. If we consider this place, if that is divisible by 2, 4, 6, 8, then this whole number is divisible by 2. This is the first divisibility test. Next is divisible by 3. So a number is divisible by 3 if the sum of the numbers is divisible by 3. Let us consider example 5, 9, 2, 4, 8, 2. Let us consider this example. So we'll just add. What will be the number? It will be 10, 14, 16, 16, 21, 30. 30 is divisible by 3. Therefore, this whole number, that is 592482, is divisible by 3. This can be concluded. The another test for divisibility is divisible by 4. Divisible by 4. A number is divisible by 4 if the number formed by the last two digits is divisible by 4. That is, example 89264 is divisible by 4 since the number formed by the last two digits 48 is divisible by 4. So the whole number is divisible by 4. This is what actually is telling. So here are some of the techniques by which we can say that the numbers are easily divisible. For this, you can refer R.S. Agarwal textbook. He has given the best way of solving the aptitude type of questions. So let's go to another session. So if you want to divide a number by 5, so how do you know that it will be divisible by 5 or any other number? Just check. The number is divisible by 5 if the units place is divisible by 0 or 5. And if you want to divide a number by 6, and how do you know it is perfectly divisible without any decimal points? A number is divisible by 6 if the number is divisible by both 2 and 3. We learned it, right? How a number is divisible by 2 and 3? We have to check whether the unit space is divisible by 2, and for 3 we have to add all numbers. If the sum is equals to the number, perfect number, which is divisible by 3, then it is divisible by 3. Then for 6 we have to check whether it is divisible by 2 or 3. No, for both should be divisible. Other number 8. So a number is divisible by 8 if the number formed by last 3 numbers is divisible by 8. Last 3 numbers. And let's move on to other numbers. So to know a number is divisible by 9 or not, we have to check whether the sum of the all numbers, if a number is given like this, if the sum of the all numbers is divisible by 9, then that number is divisible by 9. Divisible by 10 is nothing but if the last place is ending with a 0. That means a unit place is ending with a 0, then this number is divisible by 10. Next, divisible by 11. This is a bit tricky. See the places. This is odd place. These are odd places, right? So the sum of even places, and sum of odd places difference is equals to 11 or 0, then this number is divisible by 11. Bit tricky, right? Yes, nothing. It's nothing. We have to take the sum of the odd places, then sum of the even places, and take the difference of those. If we are getting 11 or 0, then that number is divisible by 11. For 12, we have to check whether it is divisible by 4 and 3. It should be divisible by 4 and 3. So likewise, we can check the divisibility. Let's move on to progressions. So what is a progression? It is succession of numbers formed and arranged in a definite order according to certain definite rules is called a progression. There are different kinds of progression like arithmetic progression, geometric progression, etc. So what is an arithmetic progression? We can name it as AP, arithmetic progression. If each term of the progression differs from its preceding term by a constant, then such a progression is called arithmetical progression. It consists of difference is called the constant, difference is called common difference of AP. So in AP with first term A and the common difference D can be defined as A, comma A plus D, comma A plus 2D. This is a common, we have a common difference here. The nth term is Tn is equals to a into n minus 1 of t. There will be n minus numbers, right? So the sum of the whole terms is Sn is equals to n by 2 into 2a plus n minus 1 into d is equals to n by 2. First term plus last term. So let us discuss some important results of arithmetic progression. If we are adding 1 plus 2 plus 3 plus so on up to n terms, then it is equals to n into n plus 1 by 2. We have very big proofs for this, and now we are not going to solve that because it takes lots of time. Then another thing is another equation, 1 square plus 2 square plus 3 square plus so on plus n square, then it is equals to n into n plus 1 into 2n plus 1 by 6. See, we have to note down such formulas. And there are no squares here, there are squares here. You have to remember n into n plus 1 into 2n plus 1 by 6. This is n into n plus 1 by 2. Is the last result 1 cube plus 2 cube plus 3 cube so on up to n cube. Then it will become n square into n plus 1 whole square by 4. This we should remember. Next comes geometric progression GP. So how you define it? A progression of numbers in which every term bears a constant ratio with its preceding term is called a geometrical progression. The constant ratio is called common ratio of GP. A GP with first term A and the common ratio R is, so let us consider the first term as A and common ratio as R. Then it is defined as A comma AR comma AR square AR cube so on. Okay. Then total number of terms will be Tn. Wait a second. Tn is equals to A into R power n minus 1. Before also in A table, if all n minus 1 terms, that is in Tn, A into n minus 1 into D. Here it is A into R power n minus 1. R is the common ratio and n is total number of terms. And Sn, what is Sn defined as? Sum of the numbers. Sum of the n terms is A into 1 minus R power n by 1 minus R. 1 minus R power n by 1 minus R. This is nth term. This is nth term. This is total number of terms. That is sum. This is T. So let us discuss a question in this. Solve this. What is it asking? What is the maximum value of Q? He is asking. So he's asking maximum value of Q. So how will find out the maximum value of Q? So let's analyze this. It is 5P 9, 3R 7 and 2Q 8. It's all sum is equals to 1114. Okay. Now what is sum of all this is 24. Okay, 4 we got. And the last number is 10 plus 1. Just consider this as 11. What is the middle number? 1. So it should be 1 here to get 11. So it is very much easy. Just write this kind of numbers here. Just write this number. No need of all this analysis. Just write 1114 so that you can easily find out in the next sessions. So how is this possible? Then it is clear that 2 plus P plus R plus A Q is equals to 11. See, 11. So if you consider P and Q as zeros, then Q is equals to 11 minus 2, that is equals to 9. So the maximum value of Q is 9. Okay. Let's move on to some stupid questions like this so that you guys will easily understand it.